Stand by for your Last Aviation link when we're going to go to Palmer and see how they fix aircraft engines. We're here at Palmer at Custom Aircraft Incorporated, and we're going to talk to Richard Walker, who's going to tell us all about how you test an aircraft engine and what you use to do it with.
Since taking over at Custom Aircraft Inc. in 2012, Richard Walker has seen the company bring on several new machines and improved methods for diagnosing and overhauling aircraft engines, and he was more than happy to share them with us today.
Call it a honing machine, but it's specially designed to run these stones inside of a cylinder in order to clean up the bore. They'll come in all rusty and carboned up and have scratches and ring marks in them and all kinds of things. And so this machine cleans them up, and then we can even resize them. The bores even some of them have taper so that they're choked down at the bottom of the bore, and we can resize all that stuff with this machine. Magnaflux is actually a brand, but it's it's called magnetic particle inspection. Yeah. So you take any ferrous metal, steel parts, and magnetize them two different directions, flood the part. It's actually got some fluorescing stuff in it. So you magnetize it, flood it, and then inspect it. That's the reason for the curtain in the black is you inspect it with a black light, and it lights up. Anywhere the iron filings congregate, it makes it bright green. So it's pretty cool. And where there's a crack, it gets interrupted and it comes to the surface. Exactly. And then the filings attract there. I mean, it just looks like fuzz, or it looks like a green line. So nice. And then you switch everything over and demagnetize it, and hopefully it's good, and off you go. Something we've just got into fairly recently, the cylinder porting and flow matching. That's what Steve's working on there. We take and reprofile mostly on the intake, but the exhaust ports as well, in order to make them flow better and run more efficiently. That's essentially what we're doing, is we're making sure all these holes match, and then we recontour and oh yeah, good point. Nice. And texture the surface also. The surface texture is actually important. One of the most important pieces to porting is, air likes to flow straight, right? It doesn't like to turn corners. So we pay a lot of attention to all the turns and making them as smooth as possible. We also have a service where we strip them down, take the paint off of the head, and put a conversion coating on it called Allodyne. That's that brown coating there. And then we'll paint the steel barrel so it doesn't rust, but removing the paint from the cylinder head actually makes them cool a little bit better. From the factory, the machine, the cutter went in, and that's right where it stopped. But now you've got a big ridge right there that is going to resist flow. So we remove all of that ridge and make that whole area smooth, so the air coming in and around the backside and flowing around doesn't have this lip to travel over and make it disrupted. So this machine here is a computerized crankshaft balancer, so it will dynamically spin the crankshaft at several different set speeds. This transducer device here detects the out of balance and then tells us where it's at, so we can verify it, which adds to reliability because stuff isn't shaking as bad. Normally in the past we might have a crankshaft that's out of whack. Well, we would never know, because we never checked it previously. And you're not required to check it either, but now we can, and not only can we check it, now we can make it even better than the factory did.
So we've heard from Richard all about these engines and the parts and all of the ways that they fix an aircraft engine, 100-year-old aircraft engines. I'm Rob Stapleton for your Last Aviation link.